We are asked to find the derivative of this equation. And when we look at this, we're used to solving for y and then taking the derivative. But if we solve for y here, we'd get a big old mess. So we're going to use implicit differentiation instead. That's where we leave it as is, and we're just going to differentiate, but we have to make sure we keep track of those y primes. So this first part, this is actually product rule. So first times the derivative of the second, which is y, then y prime. Okay, and you could also use, if you wanted, dy dx, whatever's easiest. A lot of times I'm working thing, I prefer the y prime just simply because it's neater, plus the derivative of the first times the second, and then down here this is going to be 8x, and then this is 0. Now what I need to do is I need to isolate this term right here. So I am going to move everything else over there. So I have 2x to the third y. I'm just reordering that. And then over here I'm going to have 8x, I move that over, minus 3x squared y squared. And then I also have that y prime there. And then I'm going to divide by this. So then this right here is my derivative. At this point I can look at this and go, hey, I can cancel out a x. So I'm going to do that. So you can see how there's an x in every term. So I'm going to get 8 minus 3xy squared over 2x squared y. And that's as far as I can go, because at that point there's nothing else with that 8, and that 3 can't take a 2 out. I really just factored out an x out of both, and I canceled it. Anything you can do to clean up, and again, depending on what you were doing with it, and I've said that before in some other videos recently, that depending on what you're doing with it depends on how much cleanup you want to do. A lot of times if you're turning around and putting it in something else, a lot of cleanup is worthwhile. If you're just throwing some numbers in it, maybe not as much. Format really depends on what you plan on doing with that equation.